Hey, today we're going to talk about 6.2 global energy consumption. So take a moment, check out the Enduring Understanding, look at the learning objective, pause the video, review the essential knowledge, and set up your Cornell notes. So globally, the standard of living indicates the amount of energy that a country would use on average. And the United States has a very high standard of living. We're a much wealthier country than most. Americans use about 5 times more energy than the global average. And across the board, as the standard of living increases, energy use also increases. Now, there are anomalies and there are outliers. However, this is a general trend. This is because we have more available or access to energy. We have better energy pricing because of this access. And we have government regulation, so it is available and there's a lot less corruption surrounding the energy. However, there's issues in and of the government regulations because of the policies, but that's another story. This map right here kind of gives a correlation between standard of living, or the level of developed, how developed a country is. You'll see United States, Canada, Europe, Australia, Japan. We are, the developed world. And as we look at this energy use per capita, Canada, United States are really high. Australia is relatively high. Europe is higher. But these least developed countries in sub-Saharan Africa are also the ones that are using the least energy per capita. There's one anomaly I see. This is Saudi Arabia right here, and Saudi Arabia is a very oil-rich, petroleum-rich country, so I imagine that is one of the reasons why this is an outlier. Now, this value right here, 572 exajoules, that is actually 1 million terajoules, which is, 1,000 gigajoules, which, there's conversions that you can do, and you can look at one of my supporting documents for the relationships between these prefixes. But when you convert exajoules into terawatt hours, it's this 158,839 terawatt hours globally. All right, globally, the energy consumption these are all of the types of sources that we get our energy from. Obviously, it's increased since actually it's been steadily increasing since we've introduced these sources of energy. But the number one by far is fossil fuels. Number two is hydroelectric. And third is nuclear energy. And we will talk about all of these in a future video. Okay, we're going to practice with a little bit of math. So the question reads, it's the same graph, but based on an annual consumption of 48,259 terawatt hours, calculate the oil consumption per person per day in kilowatt hours. Now, this is the 2020 values. It's not listed in the question. However, this is how much was used in 2020 globally. So when it says annual consumption, this means the whole planet, the whole globe, and it means per year. So I'm going to go through and I'm going to annotate this and find my given and find my unknown. My given is the value of terawatt hours. My unknown is kilowatt hours, but it's also per person per day. But really, I want the kilowatt hours. So when I get kilowatt hours, I know that I'm completed and I'm done with my math. So first thing I want to do is set up my grid. And this grid is not just incorporating the numbers, but I also need to do a couple of conversions. So I'm going to be switching between terawatt hours to kilowatt hours. But that's not the only move that I'm making. I want to go from an annual consumption, in other words, an entire year, to 1 day. So I have to make that conversion as well. But the other thing I want to do is go from the global annual consumption to the consumption per person. So I have to go from the global population to an individual person. So there's a few different conversions I have to make, and that's why I'm kind of walking you through this math problem right now, because it's a little bit more complicated. So we're going to start out 48,259 terawatt hours now per planet, per the entire global population per year. This is the way it's written. It's 48,259 terawatt hours per planet per year. That's how you would read it, but that's not how you write it. So because it's per planet per year, this is how it's written. Okay? That dot just means that we're multiplying. Now, what I want to do is I'm going to cancel the planet, because the planet is composed of 7.9 billion people. And people, person, same thing. So once I get this conversion done, I'm actually going to be at my final value per person. So I don't need to do any more conversions with the amount of people. So I can jump now and get rid of this year, and I want to get it to per day. So what I will do is 1 year is 365 days. If you notice, now I'm per person per day, and that's great. Now the next thing I want to do is get rid of this terawatt hours, and I want to figure out how to convert it to kilowatt hours. So the first thing I can do is convert terawatts to gigawatts. 1,000 gigawatts is 1 terawatt. That's just the prefix. So right now I've made a conversion. I want to get from giga. Giga is a million times bigger than a kilo, but I'm going to take this stepwise, and I'm going to go gigawatt hour, convert it to megawatt hour, and from megawatt hour, I'm going to convert it to kilowatt hour. Oh look, kilowatt hour per person per day. I can stop. And now all I'm doing is multiplying and then dividing, and my final value is 16.7 kilowatt hours. It's per person per day. And that, my friends, is a long math problem. But if you follow the steps, as I always say, you will be successful. Over time, the United States has increased our use of energy. However, there's a couple of interesting trends, and this is actually a good thing, is we are reducing our reliance on coal. We are finding new ways of obtaining natural gas, and we are kind of all over the place with our petroleum. But a couple of other things are good. We are increasing our renewables, and we're kind of leveling out, but we did have an increase in the amount of nuclear energy throughout the 60s and 70s, and then it's kind of leveled out. But we'll be discussing global sources of energy throughout this entire unit. I just wanted to show you this graph so you had a little bit of more of a picture of what we've done in the United States. So what can the government do to control our energy consumption? Things that we can do is you can mandate like the percent of our energy sources. In other words, by 2025, the United States says we should have 25% of our energy should be renewable energy sources. The government can increase taxes on fuel, so they discourage the use. If you're paying more in taxes, it might be better to find an alternative source. We can also offer rebates or perks if people have renewable energy sources. For one thing, if you get your electricity from wind-powered electricity, you may get a rebate from the government. You may get a tax break if you're a homeowner, even if you're a renter. Things that the government cannot do is they can't raise or lower the gas prices. If you made the gas $10 a gallon, people probably wouldn't drive as much. In fact, in Europe, the gas is far more expensive. In fact, 1 gallon is about 4 liters, and the price per liter in Europe is the same as the price per gallon here. So if it's $2.50 per gallon, it's roughly $2.50 per liter in Europe. So that means the gasoline is almost or around 4 times more expensive in Europe, which is why people in European countries tend to rely more on public transportation, because driving your own private car is a little bit more expensive. So, FRQ practice. Now, I am thinking that this reduction in 2019, we had 53,303 terawatt hours, and this is for oil. In 2020, we had 48,259. I'm thinking that this is because of the COVID pandemic. I'm thinking people were probably driving less because you're not going to work, you're working from home. I imagine this is why. I'm not 100% sure, but this is what I would suspect. However, That's not what we're looking for. The question reads, global oil consumption declined from 53,303 terawatt hours in 2019 to 48,259 terawatt hours in 2020. Calculate the percent change in global oil consumption. This is a fairly straightforward question. I hope that this video has been informative, and I thank you for your attention. I will see you soon.